Alright, geometry classes, this is Mr. Kim. Again, sorry I couldn't be here. I'm going to be in a training on campus all day, so if you have any questions, I will be here after school. Or you can email me, or you can watch this video again on my website. Hope you have your homework out, you're ready to trade in grade, and here we go in 3, 2, and 1. Alright, so here are your answers. Each problem is worth 1 point, so we're not going to have too many points here because we didn't. I know there's a lot of work, but we didn't have that many problems. Just a couple heads up. These are just the descriptions of the angles of complementary, supplementary, vertical angles, linear pairs. So as long as they've got something similar to these descriptions, we're good. Over here are the problems where we need to give which angles are congruent and why. So I've given congruent complements theorem, right angle congruence theorem. The given, someone might have put, congruent complements theorem. That's okay, because as long as there's a reason here, I'm pretty much good. So I'm being very lenient. For these two, it has to be congruent supplements theorem. This one has to be right angle congruence theorem. And over here, the V stands for vertical angles, and the RT stands for right angle congruence theorem. Ran out of space, so I had to improvise. Over here, these are all worth 1 point total, meaning the problems are 1 point. So if they miss half the problem, we're just going to mark it wrong. No half points. Same thing with down here. Teacher, please pause the video at this time so that the students can finish this part because there's going to be one more slide. Thank you. Alright, we're going to move on to the next slide. Hopefully you're all done. Here we go in 3, 2, and 1. Alright, these are the proofs. This is the one big proof that you had. 7 steps. The given, supplements, and a pair of congruent angles. Using the definition of supplementary, we're going to set them equal to 180. We're also going to do the definition of congruent angles, changing the congruent symbols to equal signs and adding the measure symbols. We can then use the transitive property over here because both of these sets equal 180, so these two pairs equal each other. And then we're going to substitute, and you could have chose angle 4 to substitute for, which is what I did, or you could have chose angle 1, so you can have either 2 angle 4s or 2 angle 1s. Doesn't really matter, because the idea is if they're the same, you're going to subtract them anyway, using the subtraction property, and then you're going to have the definition of congruent angles as your last reason. Over here, this proof is just the steps that you have to fill in. I know the directions told you to write them all out, so look through, and obviously this is a reason, this is a reason, this is a statement, this is a reason. So yeah, grade that way. Again, 1 point per problem, so if they miss anything here, -1. If they miss anything here, -1. If they made this really short, like they went straight from here kind of to the end, we're going to mark that wrong because the directions said to actually prove the theorem, prove why it works. So in other words, you have to do it the long way, the step-by-step method, without any shortcuts. Alright, teacher, please pause this video for students to finish up the rest of the homework. Remember the score 4-3-2. Thank you. Alright, hope you're ready to move on. We are moving on to our lesson, so you should have some notes out. We have 3 proofs we're going to do today, lots of drawing. So make sure you have something that's more than one color, maybe 2 or 3, that would help. And also that you try to draw nicely today, because if you don't draw nicely, it's going to get messy. Once again, this is going to be on my website, so you can then look at the video again anytime you want and try to figure out the drawings better that way. Here we go. 2-7, prove angle pair relationships, part 2. What you're going to do today is basically practice proofs using all the things that we learned yesterday. Again, on my website, I've updated the reasons list to include everything from yesterday. So it's getting pretty long. So it's in the 20s now. So there's 20 some odd reasons we can use for proofs. And it doesn't mean we're going to use all of them, but it just means there's 20 of them we can use. So hopefully you're looking at that, you're understanding that list. Moving on, 3, 2, and 1. Here's your first diagram. Angle EFG and HIJ are right angles. So right angles means we have 90-degree angles. Right angles also means we can say they're congruent. Right? So these are the things that should be firing in your head. We also have a pair of congruent angles. Prove EFC congruent to HIA. So first, there's a lot of angles going on here. So in a different color, I'm going to underline or highlight my proof statement. And while you guys are copying this down, just look at what I'm doing. And I'm just going to identify what I need to do. So what I need to do is get angle EFC and angle HIA congruent. All right. Now, the problem does mention that these are right angles. So I'm going to, in green, kind of highlight this section. That means EFG is a right angle and HIJ or JIH, doesn't matter. Those are right angles. So then, since these are right angles, we can prove that these are, actually we don't have to. I forgot. the problem already says CFG is congruent to AIJ. So in other words, these angles are already congruent. So based on these two being congruent, and we already know that these are 90, that means they are complementary. So what we can say basically is that these angles are complementary because of right angles, right, 90 degrees. And they're also complementary, since they're complementary to the same angle pair that is also congruent, then these are congruent. That's going to be a three-step proof. Right? So let me rewrite from the beginning, and I'll use a different color. Here we go. Angle EFG and angle HIJ are right angles. Sorry, the writing's messy. Angle CFG congruent to angle AIJ. So that's going to be given. That'll be your first reason. Alright, so based on right angles, we know that angles are complementary. So we can say angle angle EFC and angle CFG are complements. We can also say that these two are complements as well. HIA and angle AIJ are complements as well, because that's going to come from the definition of complementary angles. Actually, sorry, definition of right angles. Because things add up to 90 degrees, and if things add up to 90 degrees, you've got complementary angles. Alright, so since these are complementary, take a look right here. This clues angle CFG, right? If you look right here, CFG and AIJ are already used, so we know that they're already congruent to each other because the given says so. So since they're congruent to each other, then by the congruent complements theorem, these two angles must be congruent also, because they both add up to whatever these are. So our final reason is going to be angle EFC congruent to angle HIA, congruent complements theorem. Right, so these new theorems actually shorten our work a little bit because we don't have to do all these different proofs with angles. We don't have to like add things to 90 and do it this quote really long way. We can bypass all those adding and subtracting properties because we have these new theorems that allow us to basically go from right angles to complementary angles to congruent angles. So that's the importance of these new theorems. Hopefully that makes sense. Give you another 3 seconds to copy, 2 and 1, and we're going to move on. Alright, next problem given. AB is perpendicular to AD. So let's while you guys are, actually let me just read it. AB perpendicular to AD, CD perpendicular to CB. So if lines are perpendicular, that means we've got right angles. If we've got right angles, then we can say complementary, we can say right angles are congruent to each other, we can say right angles are 90 degrees. So there's all these things that happen just because of perpendicular lines. Angle A congruent to angle D, angle B congruent to angle C. We're going to prove that other lines are perpendicular. So let's start with we'll prove again. We're going to prove that AD is perpendicular to DC. So that's our first goal, and then our second goal is AB perpendicular to BC. So the blue is our goal. That's what we want to do. What do we have that's given? I'll use green. The given part says AB is perpendicular AD. So the given part says this is perpendicular and this is perpendicular. We also say that angle A is congruent to angle D. So angle A, this angle, is congruent to angle D, and angle B is congruent to angle C. Now you might be noticing that I'm not putting right angle symbols here, and the reason I'm not putting right angle symbols is because we haven't established that yet. We're going to use right angles because of perpendicular, but they didn't tell us that there's right angles, so we have to say that we've got right angles, which leads us to our proof. So if you kind of look, right, if these are congruent and these are congruent, then all we have to do is kind of trade places and say, look, the blue is what we're trying to prove. So if if these are right angles, then these are right angles because they're congruent. If this is a right angle, these lines have to be perpendicular. That's the definition of perpendicular lines. Same thing over here. Green is what we have, so green is going to be a right angle, we know that. But it's also congruent to angle B, so that means B is a right angle. If B is a right angle, then these lines are perpendicular. So I hope you understand what I'm trying to get at. All right, so again, I forgot to underline or circle this. All right, here we go. I'm going to rewrite the given. All right, AB perpendicular to AD, CD perpendicular to CB, and angle A congruent to angle D, angle B congruent to angle C. All right, so here's our given. And again, you cannot just put G. All right, so we're kind of gonna do what I already said. Using the definition of perpendicular lines, we're gonna establish that we have right angles. So the perpendicular lines that we have are the green ones. So we can only talk about these angles right now. Okay, so angle A and angle C are right angles. And that's the definition of perpendicular lines, because perpendicular lines means that there are right angles being created. Now, in order to get these involved, we have to establish that these are congruent. Since both of them are right angles now, so I'm going to redraw in red, both of them are right angles now, that means both of them are congruent to each other, and that's going to be, oops, let me draw the arrow this way maybe. And that's going to be right angle congruence theorem. So angle A congruent to angle C. That's going to be right angle congruence theorem, which basically says all right angles are congruent. Now, I'm going to take your attention over here to our second part of the given. Angle A is congruent to angle D, so we can substitute that here. We can also substitute angle B for angle C right here. And when we do that, we're going to establish that these two are now congruent. If they're congruent, right, then that means they're right angles. So therefore, if they're right angles, we've got perpendicular lines. So let's do that. Over here, link and link together. We're going to say angle D congruent. Angle D congruent to angle C. That's going to be not C, sorry, B. That's going to be substitution. And the reason we can do it in one step is because we just substituted the left and the right side individually. And since I need a congruent sign. And since angle D and angle B are congruent, they're congruent, we've already established that they're congruent to these, and these were right angles, so now we have to state that these are right angles. That's a horrible arrow. Angle D and angle B are right angles. It's going to be definition of right angles, because right angles are 90 degrees, right? And since we already established that we've got right angles here, and these were substituted, therefore these are also right angles. I hope you understand the logic. All right, from there, since angle D and angle B are right angles, now if you look at the diagram, I'm going to replace these angle signs. Now, since they're right angles, well, now the lines are perpendicular. The ones in the blue are perpendicular, which is what we had to prove. So now we can write the proof statement. AD perpendicular to DC, AB perpendicular to BC, and that's going to be definition of perpendicular lines. Alright, so that's proof number 2. Again, we kind of went forward and backward, if that makes any sense. Alright, and 3, 2, and 1, we are going to change. Let me count down again. Maybe you're not done. 3, 2, 1. Alright, last proof, and this will be it. Given AB perpendicular to AD. No, that's not it. Wait, what happened? There we go. Given angle 1 and angle 2 are complements, angle 3 and angle 4 are complements, prove angle 2 congruent to angle 3. Again, while you guys are writing this down, I'm going to highlight what we do need to prove in blue. We need to prove angle 2 and angle 3 are congruent. Somehow we need to get that congruent. I'm not going to mark them congruent yet. And we say, if the problem tells us that angle 1 and angle 2 are complements, which means they add up to 90 degrees. So I'm going to draw like a big right angle here. Angle 3 and 4 are complements, so I'm going to draw like a funky right angle here. I know it doesn't really match up, but I'm trying to visually show you what we have. So if that's what we have, based on what I see, we can establish that these are congruent here because of vertical angles, because these two lines are crossing. And if angle 1 and 4 are congruent, and 3 and 4 and 2 and 1 are complementary, then therefore angle 2 and 3 must be congruent. Congruent complements theorem. All right, so here we go. Given. And I know some of you still might be copying, but just catch up. You'll be fine. This video is on my website again. Angle 2 are complements. Angle 3 and angle 4 are complements. It's going to be given. Again, the drawing tells us we've got vertical angles at 1 and 4, so we're going to use that. It's unrelated to the complementary, though, so we're not going to link them together. I'm just going to say angle 1 congruent to angle 4. That's going to be vertical angles. Alright, now we're going to link the two together. Since angle 1 is congruent to angle 4, and we've already established that 1 plus 2 is complementary and 3 plus 4 is complementary. Because they're both complementary to the same pair of congruent angles, that means they must be congruent to each other because they add up to be the same values to 90 as with 1 and 4. So 1 plus 2 is 90, 3 plus 4 is 90. Well, since 1 and 4 are equal, 3 and 2 must be equal. So it's almost like a transitive property, but it's not, but it kind of is. Alright, so angle 2 congruent to angle 3, congruent complements theorem. Alright, so that's pretty much it for me. Alright, this is the last proof. Again, it's on my website. Hopefully you got this down. On your homework tonight, you're going to be doing a bunch of proofs. Okay, not by a bunch, I don't mean like 20. I just mean, a good amount. Again, use flow maps, draw the diagram, figure out what you have, figure out what you need. And that's kind of the way to go. The reasons list on my website, make sure you look at that too. Good luck, and we will see you tomorrow.